Hi, everybody, and welcome to week 4. Um, everybody is mostly doing a great job keeping up. A couple notes on things I want you to be aware of. The grade book, you should have gone by now to click grades in my courses. And there you will see all of your grades. Your expert TA grades will be mapped over. You'll also see grades from your first two labs, Lab 0 and Lab 1, as well as feedback on those. The pivot analyzing motion activities are moved over once a week. So if you've done one in pivot, it's showing up in pivot, but it's not yet in my courses. That's okay. We have to manually move those over. So make sure that you're aware of what's happening with your grades and reach out with any questions or concerns. We have our second quiz that's going to be due on Monday of week 4. That's going to be our standard quiz deadline moving forward. And so hopefully that quiz environment is familiar. And again, there's the example format. If you didn't look through that the first time, you want to do that before this next quiz. Also, don't forget that I do post daily check full written explained solutions. So looking through those for the week and for the module before taking the quiz can be very, very helpful. All right, so what I wanted to talk about in this brief video for the start of the week is a common issue on the last lab regarding this idea of camera angle. And also the distance between an object and the calibration length. So I wanted to just kind of give a couple demonstrations to supplement what's in those slides that's in your Google Drive. So I'm going to talk about that. We'll keep coming back to this. This is really important because when we're making measurements using a two-dimensional video that we're calibrating, we really have to understand how these things can impact it. You're going to be using your own video analysis for your midterm and final exam projects. So it's very important for those as well, because part of that will be a discussion of the impacts on camera angle and calibration. Okay, here goes. Let's talk first about one that's a little bit, I think, easier to visualize. And I have two pencils. So I have an orange and a blue pencil, and right now they're side by side, and you can see they are the same length. So I also have my ruler, and it's easier to see the inches than the centimeters. So I'm going to be a bad physicist and use inches. And we can see that the pencils are just about 7 inches. So if I put them side by side, right, we can see that they both measure 7 inches. So let's say in a video, I had these two pencils and I use the orange pencil to calibrate. So I leave the orange pencil here. I put the calibration information in. That gives me this set. Pretend this ruler that I'm holding is like the ruler that Pivot gives you. That's my calibration ruler, right? So what happens then when I move the pen forward, or the pencil forward? It looks a lot bigger. So now the blue pencil, if I was going to measure it using my calibration ruler, is going to be wildly off because I moved it closer to the camera than the calibration. And let me turn sideways so you can see I didn't move it a ton. I just moved it, probably about 3 or 4 inches, and it's making about, now it looks to be just about, if I keep it at that length, just about 9 inches long. And then likewise, if I instead, now they're side by side again, same size, calibration, this is what I basically tell Pivot, this is the size of everything in this video. If I move this backwards towards me, we can see that it's substantially smaller. So my position measurements would be smaller than they really are. And again, I didn't move it a ton. And so the distance between the object and the calibration length really, really matters. And that the closer the object is, then the thing that was calibrated to, then your position measurements are too big. And if it's further away, they're too small. So those are the first parts of the slide. So go back and take a look at those slides. make sure that makes sense, because that's going to be a really big issue that we do encounter, because we have to look at a video and say, you know what, I need to calibrate the size of this video somehow. How am I going to do that? Oh, like maybe I know the height of her glasses or the typical height of a human head. But then if something's closer or further away than my head, then you're not going to get accurate measurements. So you need to know what sort of systematic error that is going to be causing. Okay, now let's talk about one that's a little bit harder to demonstrate on this scale, but I'm going to try. Let's say that I have now the camera angle. So right now the camera is perpendicular to me. So let's say that I calibrated the camera so that it is perpendicular, right? This would be the one where the camera is actually then pointed down on something, right? So imagine kind of looking at something falling and then the camera pans down. So what I'm going to do to kind of mimic that is show that, let's say that now, let's say I have this pointed down and then here's my perpendicular calibration length, because in pivot, it never changes the spacing between all of the markers, right? No matter what you calibrate to, it's assuming that that's the perpendicular calibration length. But then if something's falling, right, and you're looking, say, down on it, you can see that already this pen looks like it goes from around 8 to 13. That's only 5 inches, right? So when you're not looking perpendicularly to get the full length, 7 inches, then something looks substantially shorter, right? So the less perpendicular you are, the smaller your measurements will be. So this is what happened in lab 1 with the free fall. The calibration was set, and then the camera view was looking down at the bottom of the motion. So those position measurements, because they had like at a downward angle, were smaller than they should be. And because that camera angle skewed those position measurements smaller, then it didn't look like it was accelerating as much as it really is. It's really accelerating at 9.8. We know that, but we all measured values much less or significantly within our error, less than 9.8. And again, that's okay from an experimental point of view. We just have to understand why it's different. A large part of physics and physics labs is not to get the right answer. That's not it at all. The reason that we really do labs in our teaching classes is to add to our ability to critically think about the world, because in every experiment, there is some sort of random error, fluctuations, and some systematic error that's going to skew your results. And we have to be aware of what those are, and the process of learning about those, thinking about those, identifying those. This is a big, giant learning goal for this course, so that when you're out in the world doing anything technical or that involves, a result, you can think critically about the sorts of things that might be causing it. Sure, you might not be doing video analysis, but it's the idea that we're critically analyzing what we're doing. So when we go through these pivot labs, our goal is to do the analysis correctly from a theoretical standpoint, but also to develop the ability to think about what's happening in our measurements, what could be causing them to be wrong, and if we had to go back and do a better version of this experiment, what would we do? And that's really at the heart of physics and critical thinking. That is, the reason that this course is very often required. So, okay, hopefully that helped clear it up. Take what I said in this video, look back at those slides that are posted. We are not leaving this issue of camera angle or calibration length alone. They are different. The calibration length, again, one hand looks big, one hand looks small, right, relative. And then the other one would be the kind of downward skew that you get when you're not looking perpendicular. I hope this helps clear things up. Reach out with questions. It'll come up again in this coming lab, as well as future labs and your individual projects. All right. Great job, everybody. I hope everybody's having a great start to your summer, and reach out. Oh, and again, thank you to Rob, our awesome TA. I hope that you're making use of his posted help sessions. So please do that. All right. Take care.